All right, kids, so if you didn't do so hot on the quiz, what I'm gonna do is just make a little video to help go over some of the concepts you might have been struggling with. So first of all, we have this element carbon. So carbon has an atomic number of 6, meaning on the periodic table, it's going to be the 6th one listed. So this is then also the number of protons that the element has. So atomic number 6 refers to how many protons. Now remember, protons are the positive charges in an atom. So this is atomic number of protons. Down here, this is the atomic mass. So what this is just a combination of the protons and the neutrons. The neutrons are neutral. They don't do anything in an atom. However, they give it weight or mass. So you have to, in order to find the atomic mass of an atom, you simply add up the protons and neutrons. And then electrons, even though they have a negative charge, they don't have weight. So we don't have much weight. So we don't even count them for the atomic mass. So this number here, the atomic mass, is the number of protons plus neutrons. So if you have 6 protons, you're going to round this to 12. Then you also have 6 neutrons. So if I ask you how many neutrons are in an element of carbon, an atom of a carbon atom, you would tell me 6. All right, so that's atomic number, atomic mass. This is the element's symbol and then the element's name. All right, if we were to write this on our board, to draw this, we would say carbon has 6 protons. It also has 6 neutrons. So we're going to put this in a box because it's in the nucleus. All right, and then if we're going to do the electrons, we're also going to do them in shells. Now remember, the electron shells or energy level, the first shell can hold 2, so we're going to put 1, 2. The second shell can hold up to 8. Well, we only need 6 because however many protons there are, that's how many electrons we have. So we already have 2, so we only need 4 more. So we would say 1, 2, 3, 4. So this is the electron configuration for carbon. Now, the other aspect I need you to know is that if we were to write this in a Lewis dot diagram, we would also write, let's go over here a little bit, because the Lewis dot diagram only takes into account these outer electrons, which we call the valence electrons, we're going to write the symbol for carbon over here. And then, because we saw that there were 1, 2, 3, 4 valence electrons, so remember 1, 2, 3, 4 on its outermost shell. So whatever's on the outermost shell is represented on the Lewis dot diagram. So we would just draw this like 1, 2, 3, 4. Okay, so that is the Lewis dot diagram for carbon. We're gonna do another one just to make sure you've got this down. So here we have an atom of fluorine. So fluorine has an atomic number of 9, meaning on your periodic table, here is 1, here is 2, and then it goes across 3, 4, 5, 6. Up in the top corner, you can see where it's like labeling these in the box. Atomic number. So fluorine has an atomic number of 9. So carbon is 6, nitrogen 7, oxygen 8, fluorine is here at 9. So atomic number of 9, its atomic mass 18.99. So that's a combination of protons plus neutrons. So if we wanted to figure out neutrons, since we already know protons, we're going to round this to 19. And then we're going to subtract 9. We have 10 left. So fluorine actually has 10 neutrons. So let's draw this atom out on the table. So we're going to say protons equals 9 because it has an atomic number of 9. Neutrons equals 10. This all falls in the nucleus. Now remember, Protons have a positive charge, neutrons are neutral. Now our electrons are going to go on the shells. Now remember, inner shell can only hold 2. All right, but we need a total of 9 because it matches the protons. So then the outer shell is going to have the rest. So that's 7. 1, 2, 3, 4, 5, 6, 7. All right, so 7 valence electrons because there's 7 electrons on its outermost ring. These guys on the outside are called valence electrons. Just means they're on the outside. And while that just seems kind of weird to even know, we're going to talk more about that later. All right, so what we're going to do next is we're going to draw the Lewis dot diagram here of fluorine. So let's find a corner we can see pretty good. So since it has 7 valence electrons, we're going to put the symbol fluorine, and all we have to do is draw the valence electrons. So 1, 2, 3, 4, 5, 6, 7. And there's how you draw the Lewis dot diagram for fluorine. One last thing I want you to be aware of, there's a cheat on the periodic table. All these guys in this column here have 1 valence electron. All these guys in this column here have 2 valence electrons. We skip these transition metals in the middle. We're going to skip those. Come over here. These guys all have 3 valence electrons. These guys have 4. These guys have 5. These guys have 6. So if you were going to draw, let's say we're going to draw oxygen here, and we wanted to put it in a Lewis dot diagram, we know it's in column 16 and it has to have 6 valence electrons. So on our board, if we were going to do oxygen, we would just say 1, 2, 3, 4, 5, 6. So we can tell that without having to draw this whole model out, we can tell just by looking at the column it's in on the periodic table and how many dots it would have around it.